Question 1. To address the challenge of introducing new network services within a VMware NSX v6.2 environment while ensuring robust security and operational stability, which of the following approaches best aligns with professional best practices for risk assessment and mitigation? Option A. Conduct a thorough risk assessment to identify potential threats, vulnerabilities, and the impact of security incidents specific to the new services and the existing NSX infrastructure. Then implement controls based on the findings. Option B. Replicate the security configuration of a similar network environment that has been previously secured, assuming that the security posture will translate directly to the current deployment. Option C. Immediately deploy the most comprehensive security features available within NSX, such as advanced threat prevention and distributed firewalling, without a detailed analysis of the specific risks posed by the new services. Option D. Proceed with the implementation of the new network services, relying on general security best practices, and assuming that existing NSX security configurations will adequately protect the new components. Correct answer is A. Conduct a thorough risk assessment to identify potential threats, vulnerabilities, and the impact of security incidents specific to the new services and the existing NSX infrastructure. Then implement controls based on the findings. Explanation. The scenario presents a common challenge in network virtualization, balancing the need for robust security controls with the operational demands of a dynamic environment. The professional challenge lies in accurately assessing the risks associated with implementing new network services and ensuring that the chosen security measures are both effective and proportionate, aligning with established best practices and the implicit requirements of maintaining a secure and compliant virtual network infrastructure, as governed by the principles underlying the VMware NSX v6.2 framework. The correct approach involves a systematic risk assessment that identifies potential threats, vulnerabilities, and the likelihood and impact of security incidents. This approach is best professional practice because it provides a data-driven foundation for security decisions, ensuring that resources are allocated effectively to mitigate the most significant risks. It aligns with the principle of defense in depth and proactive security posture management, which are fundamental to secure network virtualization. By understanding the specific risks to the NSX environment, administrators can implement targeted security controls, such as microsegmentation, firewall rules, and intrusion detection/prevention, that are tailored to the unique threat landscape. This methodical process also supports auditability and compliance by documenting the rationale behind security decisions. An incorrect approach that bypasses a formal risk assessment and proceeds with implementation based on assumptions or anecdotal evidence is professionally unacceptable. This failure represents a significant regulatory and ethical lapse because it neglects the fundamental responsibility to protect sensitive data and maintain the integrity of the network. Such an approach increases the likelihood of security breaches, data loss, and service disruption, which can have severe financial and reputational consequences. It also undermines the trust placed in the IT professional to manage the network securely and responsibly. Another incorrect approach that focuses solely on implementing the most advanced security features without a clear understanding of the specific risks or operational impact is also professionally flawed. While advanced features can be beneficial, their misapplication or overimplementation can lead to unnecessary complexity, performance degradation, and operational overhead. This approach fails to demonstrate due diligence in understanding the actual threat landscape and the specific needs of the environment, potentially leading to a false sense of security or inefficient resource utilization. A third incorrect approach that relies on replicating security configurations from a different environment without a thorough assessment of the current context is also problematic. Each network environment has unique characteristics, threat vectors, and compliance requirements. Blindly copying configurations ignores these differences and can result in security gaps or misconfigurations that expose the network to undue risk. This demonstrates a lack of critical thinking and a failure to adapt security strategies to the specific operational realities. The professional decision-making process for similar situations should involve a structured risk management framework. This begins with understanding the business objectives and the criticality of the network services. Next, a comprehensive threat and vulnerability assessment specific to the NSX v6.2 environment should be conducted. This assessment should inform the selection and implementation of appropriate security controls, followed by continuous monitoring and periodic reassessment of risks. Documentation of the entire process is crucial for accountability and compliance. Question 2. The control framework reveals a scenario where a new application requiring inter-tier communication within a multi-tier application architecture is being deployed on VMware NSX v6. 2. The development team has requested broad network access between the web, application, and database tiers to facilitate rapid development and testing. As the network virtualization engineer responsible for security, what is the most appropriate approach to implementing the distributed firewall rules for this new application? Option A. Implement a single, broad distributed firewall rule that allows all traffic between the web, application, and database tiers to expedite the development and testing process. Option B. Implement distributed firewall rules based on the initial request from the development team without further validation, assuming their understanding of the application's needs is complete. Option C. Implement an implicit deny rule for all traffic, and then create exceptions for known malicious traffic patterns, assuming all other traffic is safe until proven otherwise. Option D. Implement a set of highly granular distributed firewall rules that explicitly permit only the necessary ports and protocols for communication between specific services within each tier, based on documented business requirements and the principle of least privilege. The correct answer is D. Implement a set of highly granular distributed firewall rules that explicitly permit only the necessary ports and protocols for communication between specific services within each tier, based on documented business requirements and the principle of least privilege. Explanation. The control framework reveals a critical juncture in network virtualization security, specifically concerning the implementation of distributed firewall rules within a VMware NSX v6. 2 environment. The professional challenge lies in balancing granular security policy enforcement with operational efficiency and compliance requirements. Misconfigurations can lead to security vulnerabilities, unauthorized access, or service disruptions, all of which carry significant regulatory and business implications. Adhering to the principles of least privilege and defense in depth is paramount. The correct approach involves a systematic and documented process for rule creation and modification, prioritizing the principle of least privilege. This means that each rule should grant only the minimum necessary permissions for a specific function or service to operate. This aligns with best practices in network security and is often a requirement for regulatory compliance frameworks that mandate strict access controls and auditability. By thoroughly documenting the business justification for each rule, its scope, and its expected impact, professionals ensure transparency and accountability, which are essential for audits and incident response. An incorrect approach would be to implement broad, permissive rules without sufficient justification or documentation. This violates the principle of least privilege and creates an unnecessarily large attack surface. Such an approach is professionally unacceptable, as it increases the risk of unauthorized access and data breaches, potentially leading to regulatory penalties and reputational damage. Another incorrect approach is to rely on implicit deny rules without a clear understanding of the traffic flows they are intended to block. This can lead to accidental blocking of legitimate traffic, causing service outages and operational disruptions, and demonstrates a lack of due diligence in understanding the network's security posture. Finally, implementing rules without a proper change management process, including testing and rollback plans, is a significant professional failing. This increases the risk of unintended consequences and makes it difficult to troubleshoot issues, potentially leading to prolonged downtime and non-compliance with service-level agreements. Professionals should employ a decision-making framework that emphasizes a thorough understanding of business requirements, a risk-based approach to security policy, and a robust change management process. This includes defining clear security objectives, assessing potential threats and vulnerabilities, designing policies that mitigate identified risks, and implementing those policies with rigorous testing and documentation. Continuous monitoring and periodic review of security rules are also crucial to adapt to evolving threats and business needs. Question 3. Risk assessment procedures indicate a growing concern regarding unauthorized lateral movement of threats within the organization's hybrid cloud environment, where critical applications reside on both on-premises vSphere clusters and VMware Cloud on AWS. The current network security strategy relies heavily on perimeter firewalls and basic network segmentation using VLAN. To address this, a new approach is needed to implement microsegmentation for enhanced security. Which of the following approaches best aligns with the capabilities of VMware NSX v6? 2. For achieving effective microsegmentation in this hybrid cloud scenario. Option A. Deploy a separate hardware-based firewall appliance in front of each application tier within the virtualized environment. Option B. Implement distributed firewall rules directly on the virtual machine interfaces, VNIC, using NSX security policies to enforce granular access controls between workloads. Option C. Continue to rely on perimeter firewalls and extend existing VLAN-based segmentation to the VMware cloud on AWS environment. Option D. Manually configure access control lists, ACL, on physical network switches at the edge of each data center and cloud environment to control traffic flow between virtual machines. The correct answer is B. Implement distributed firewall rules directly on the virtual machine interfaces, VNIC, using NSX security policies to enforce granular access controls between workloads. Explanation. The scenario presents a common challenge in network virtualization environments, ensuring consistent and secure network segmentation across a hybrid cloud deployment. The professional challenge lies in balancing the need for agility and rapid deployment with the imperative to maintain robust security controls and compliance with VMware's NSX v6. Two architectural principles and best practices, which are implicitly governed by the exam scope. Careful judgment is required to select an approach that is both technically sound and aligns with the operational and security objectives of the organization. The correct approach represents best professional practice because it leverages the native capabilities of NSX v6. 2. For microsegmentation, specifically by utilizing distributed firewall rules applied at the virtual machine interface, VNIC level. This granular control ensures that security policies are enforced directly where traffic enters and exits the virtual machine, regardless of its physical location or network topology. This aligns with the principle of least privilege and defense in depth, which are fundamental to secure network design and are implicitly expected within the context of the VMware NSX v6. 2. Certification. This approach minimizes the attack surface and prevents lateral movement of threats within the virtualized environment. An incorrect approach that relies solely on traditional perimeter firewalls for segmentation in a virtualized environment fails to address the dynamic nature of virtual machines and the increased risk of east-west traffic threats. This is a regulatory/ethical failure because it neglects the specific security requirements and capabilities inherent in NSX v6. 2. Potentially leading to a false sense of security and a violation of the implicit expectation to implement best-in-class virtualized security as defined by the technology's design. Another incorrect approach that involves manually configuring VLAN and access control lists, ACL, on physical network devices for virtual machine segmentation is also professionally unacceptable. This method is inefficient, prone to human error, and does not scale effectively in a virtualized environment where VMs are frequently moved, cloned, or deleted. It represents a failure to adopt the modern, software-defined networking paradigm that NSX v6 embodies, potentially leading to misconfigurations and security vulnerabilities that could have compliance implications if specific industry standards or organizational policies mandate the use of advanced network virtualization security features. The professional decision-making process for similar situations should involve a thorough understanding of the organization's security posture, compliance requirements, and the specific capabilities of the deployed network virtualization platform. Professionals should prioritize solutions that offer granular control, automation, and integration with the virtualization infrastructure, evaluating potential solutions against the principles of least privilege, defense in depth, and the specific architectural best practices of NSX v6. 2 is crucial. Furthermore, considering the operational overhead and scalability of each approach is essential for long-term success and security. Question 4. The efficiency study reveals that the current implementation of microsegmentation policies in the VMware NSX v6 environment is proving to be operationally burdensome and is not effectively mitigating internal threats. The network virtualization team is considering several strategies to improve policy enforcement and management. Which of the following strategies best aligns with the principles of microsegmentation and professional best practices for securing a virtualized network? Option A. Relying exclusively on existing physical firewall infrastructure to inspect and control traffic between virtual machines, bypassing NSX's distributed firewall capabilities. Option B. Disabling certain NSX security features to reduce processing overhead and improve network throughput, with the assumption that the physical network provides sufficient security. Option C. Implementing granular firewall rules directly on the distributed logical switches within NSX to enforce policies at the virtual machine interface. Option D. Consolidating all microsegmentation policies into a single, broad rule set applied at the edge of the virtual network to simplify management. Correct answer is C. Implementing granular firewall rules directly on the distributed logical switches within NSX to enforce policies at the virtual machine interface. Explanation: the efficiency study reveals a significant bottleneck in the deployment of microsegmentation policies within a VMware NSX v6. 2. Environment. The challenge lies in balancing granular security controls with operational overhead and potential performance impacts, especially in a production setting where downtime and misconfigurations are unacceptable. The professional must evaluate different strategies for policy enforcement and management, considering the inherent complexities of network virtualization and the specific capabilities of NSX v6. 2. The correct approach involves leveraging NSX's distributed firewall capabilities for policy enforcement at the virtual machine level. This aligns with best practices for microsegmentation by providing the most granular control and minimizing the attack surface. It also adheres to the principle of least privilege, ensuring that only necessary network traffic is permitted. From a regulatory perspective, this granular control is crucial for meeting compliance requirements that mandate strict access controls and data protection, particularly in environments handling sensitive information. This method minimizes the risk of unauthorized lateral movement of threats within the network. An incorrect approach would be to rely solely on traditional perimeter firewalls to enforce microsegmentation policies. This fails to address the east-west traffic within the virtualized environment, leaving internal systems vulnerable. It also negates the core benefits of network virtualization and NSX, leading to an inefficient and less secure architecture. Ethically, this represents a failure to implement appropriate security controls as expected in a virtualized infrastructure. Another incorrect approach would be to implement overly broad firewall rules that permit a wide range of traffic, even within segments. While this might reduce immediate operational complexity, it undermines the principle of least privilege and significantly increases the attack surface. This approach is professionally negligent as it fails to provide adequate security and could lead to compliance violations if specific data protection mandates are not met. A further incorrect approach would be to disable security features or bypass policy enforcement mechanisms to improve performance without a thorough risk assessment and documented exception process. This is a direct violation of security best practices and could lead to severe security breaches and regulatory penalties. It demonstrates a lack of due diligence and a disregard for the integrity of the security posture. The professional decision-making process should involve a thorough understanding of the NSX v6. 2. Architecture, the specific security requirements of the organization, and relevant compliance mandates. It requires a risk-based approach, prioritizing granular security controls while considering operational feasibility. When evaluating different enforcement strategies, professionals should always consider the potential impact on security posture, operational efficiency, and compliance adherence. Documenting all decisions, especially those involving deviations from standard security practices, is paramount. Question 5. Consider a scenario where a financial services organization is rapidly deploying new microservices on its VMware NSX v6 environment to meet market demands. The development team is under pressure to deliver these services quickly, and there's a temptation to expedite the deployment process by minimizing pre-deployment security checks. What is the most appropriate approach to ensure the security and integrity of the network infrastructure in this context? Option A. Rely on the default security configurations provided by VMware NSX v6. 2. and the underlying cloud platform, assuming they are sufficient for all new service deployments. Option B. Expedite the deployment by skipping the formal risk assessment and relying on the development team's informal understanding of potential security concerns. Option C. Defer all security reviews and risk assessments until after the microservices have been deployed and are in production, addressing any issues that arise reactively. Option D. Implement a comprehensive, documented risk assessment process that identifies potential threats and vulnerabilities associated with the new microservices and their integration into the NSX environment, and then implement appropriate security controls based on the assessment findings. Correct answer is D. Implement a comprehensive, documented risk assessment process that identifies potential threats and vulnerabilities associated with the new microservices and their integration into the NSX environment, and then implement appropriate security controls based on the assessment findings. Explanation: this scenario presents a professional challenge due to the inherent tension between operational efficiency and robust security posture within a virtualized network environment. The rapid deployment of new services, while crucial for business agility, introduces potential vulnerabilities if not accompanied by a thorough risk assessment. The NSX v6.2 framework, while focused on network virtualization, implicitly requires adherence to security best practices and a proactive approach to identifying and mitigating risks. The challenge lies in balancing the speed of innovation with the imperative to maintain a secure and compliant network infrastructure. The correct approach involves a systematic and documented risk assessment process that is integrated into the service deployment lifecycle. This aligns with general IT governance principles and the implicit security requirements of managing a virtualized network. By identifying potential threats, vulnerabilities, and their impact, and then implementing appropriate controls, the organization can make informed decisions about acceptable risk levels. This proactive stance is essential for maintaining the integrity and confidentiality of data, and for ensuring the availability of services, all of which are foundational to responsible IT operations. An incorrect approach would be to bypass or significantly abbreviate the risk assessment process. This failure to identify and evaluate potential security weaknesses before deployment constitutes a significant regulatory and ethical lapse. It exposes the organization to potential data breaches, service disruptions, and non-compliance with any applicable data protection regulations, even if not explicitly detailed in the NSX v6.2 exam syllabus. The underlying principles of responsible IT management and security are universal. Another incorrect approach is to rely solely on vendor-provided security defaults without independent verification. While vendors strive for secure products, their defaults may not align with an organization's specific risk appetite or regulatory obligations. This abdication of responsibility for security assurance is professionally unsound. Finally, a reactive approach, addressing security issues only after they manifest as incidents, is demonstrably poor practice. It leads to higher remediation costs, reputational damage, and potential legal repercussions. Professionals should adopt a decision-making framework that prioritizes a structured risk management process. This involves understanding the business context, identifying assets and their criticality, analyzing threats and vulnerabilities, evaluating the likelihood and impact of potential risks, and then selecting and implementing appropriate mitigation strategies. This framework should be iterative, with regular reviews and updates to reflect changes in the threat landscape and the IT environment. Question 6. The investigation demonstrates a critical security incident where unauthorized access was gained to a sensitive development environment from a less secure staging environment within a VMware NSX v6.2 deployment. The current network security policy relies on a combination of VLAN-based segmentation and basic firewall rules applied at the edge of the virtual network. The security team suspects that east-west traffic between the staging and development segments was not adequately controlled, allowing the compromise to propagate. Which of the following approaches, when implemented within the NSX v6.2 framework, would best address the root cause of this security breach and prevent similar incidents in the future? Option A. Implement granular distributed firewall (DFW) rules to enforce microsegmentation between the staging and development environments, allowing only explicitly permitted traffic. Option B. Remove all firewall rules between the staging and development environments to simplify network management and improve application performance. Option C. Configure static IP addresses for all virtual machines in both environments to simplify network address translation, NAT, configurations. Option D. Increase the capacity of the existing edge firewall to handle higher traffic volumes, assuming the breach was due to a denial of service attack, overwhelming security controls. The correct answer is A. Implement granular distributed firewall (DFW) rules to enforce microsegmentation between the staging and development environments, allowing only explicitly permitted traffic. Explanation: the investigation demonstrates a common challenge in network virtualization environments, ensuring consistent and secure network segmentation across a hybrid cloud deployment. The professional is tasked with maintaining compliance with internal security policies and potentially external regulatory requirements, though for this exam, we focus solely on the technical framework of NSX v6. 2. As the governing regulation. The challenge lies in the dynamic nature of cloud environments and the need for precise control over traffic flow between different security zones. The correct approach involves leveraging NSX distributed firewall (DFW) rules to enforce microsegmentation. This method is best professional practice because it provides granular, host-based security policies that follow the virtual machine regardless of its physical location or IP address changes. This aligns with the principle of least privilege and defense in depth, ensuring that only explicitly allowed traffic traverses between segments. The DFW's ability to apply rules at the VNIC level is crucial for maintaining security posture in a virtualized and potentially distributed environment. An incorrect approach would be to rely solely on traditional perimeter firewalls or network ACLs on physical switches. This fails to address the east-west traffic within the virtualized environment, which is a primary attack vector. Such an approach is professionally unacceptable because it creates security gaps, making the environment vulnerable to lateral movement by attackers. It also fails to meet the granular control requirements inherent in modern network virtualization security. Another incorrect approach would be to implement overly broad DFW rules, such as allowing all traffic between certain segments. This violates the principle of least privilege and significantly increases the attack surface. It is professionally unacceptable as it undermines the purpose of segmentation and microsegmentation, leading to a false sense of security. A further incorrect approach might involve disabling security features or applying weak security policies due to perceived performance impacts or complexity. This is a critical professional failure, as it prioritizes convenience or perceived efficiency over security and compliance. It demonstrates a lack of understanding of the risks associated with inadequate network security in a virtualized infrastructure. The professional decision-making process for similar situations should involve a thorough understanding of the network architecture, the data flows, and the security requirements. This includes identifying critical assets and sensitive data, defining security zones, and then meticulously designing and implementing granular security policies using the capabilities of NSX. Regular auditing and testing of these policies are essential to ensure their effectiveness and to adapt to evolving threats and network changes. Question 7. Upon reviewing the deployment plan for a new customer-facing application that handles sensitive personal data, what is the most effective initial step in assessing the associated network security risks within the NSX v6? 2. Environment. Option A. Engage with the application development team and business stakeholders to understand the application's functionality, data handling practices, and criticality to business operations. Option B. Implement a comprehensive set of restrictive NSX firewall rules across all network segments to minimize potential attack vectors. Option C. Deploy the application immediately with default NSX security policies and plan to address security concerns post-deployment. Option D. Conduct a deep vulnerability scan of the underlying XC hosts and vCenter server without specific regard to the application's network traffic patterns. The correct answer is A. Engage with the application development team and business stakeholders to understand the application's functionality, data handling practices, and criticality to business operations. Explanation. Scenario analysis. This scenario presents a common challenge in network virtualization environments. balancing the need for robust security controls with the operational requirements of a dynamic and evolving infrastructure. The professional is tasked with assessing the risk associated with a new, potentially sensitive application deployment. The challenge lies in accurately identifying and quantifying the risks without having complete visibility into the application's internal workings or its precise network traffic patterns. This requires a proactive and thorough approach to risk assessment, considering both technical vulnerabilities and potential business impacts. The absence of detailed application documentation further complicates the assessment, demanding a more investigative and collaborative approach. Correct approach analysis. The correct approach involves a multifaceted risk assessment that begins with gathering as much information as possible about the application and its intended use. This includes engaging with the application development team and business stakeholders to understand its functionality, data sensitivity, and criticality. Simultaneously, a technical assessment should be conducted to identify potential network-level vulnerabilities that could be exploited. This would involve analyzing the application's communication protocols, ports, and expected traffic flows. Based on this information, a risk matrix can be developed, mapping identified threats to potential vulnerabilities and assessing the likelihood and impact of a security incident. Implementing appropriate NSX security controls, such as microsegmentation, firewall rules, and intrusion detection/prevention, should then be prioritized based on the risk assessment findings. This approach aligns with best practices for information security risk management, emphasizing a data-driven and layered defense strategy. It ensures that security investments are targeted towards the most significant risks, providing a strong foundation for protecting the application and the broader network infrastructure. Incorrect approaches analysis. Implementing broad, overly restrictive firewall rules without a clear understanding of the application's requirements is an incorrect approach. This can lead to operational disruptions, hindering legitimate application functionality and impacting business operations. From a regulatory perspective, while security is paramount, overly restrictive controls that prevent essential business functions could be seen as a failure to adequately support business objectives, potentially leading to compliance issues if the application is critical for regulated processes. Deploying the application without any specific NSX security controls, relying solely on existing perimeter defenses, is also an incorrect and highly risky approach. This fails to acknowledge the inherent security challenges of modern application deployments and the increased attack surface within a virtualized environment. It represents a significant regulatory and ethical failure, as it demonstrates a disregard for due diligence in protecting sensitive data and critical systems, potentially violating data protection regulations, and failing to uphold the professional duty of care. Focusing solely on the technical vulnerabilities of the underlying virtual infrastructure without considering the application's specific security needs is another incorrect approach. While infrastructure security is vital, it does not address application-specific risks. This can leave the application exposed to threats that exploit its unique characteristics, leading to potential data breaches or service disruption. This approach neglects the principle of defense in depth and fails to adequately address the specific risk profile of the application being deployed. Professional reasoning. Professionals should adopt a systematic and iterative risk assessment process. This begins with understanding the business context and application requirements. Next, a thorough technical assessment of the application and its interaction with the network environment is crucial. This information should then be used to identify, analyze, and prioritize risks. Security controls should be designed and implemented based on this prioritized risk assessment, following the principle of least privilege and defense in depth. Regular review and reassessment of risks and controls are essential to adapt to evolving threats and changes in the application or environment. This structured approach ensures that security measures are effective, efficient, and aligned with business objectives, while also meeting regulatory and ethical obligations. Question 8. Compliance review shows that a critical security policy mandating microsegmentation for sensitive application tiers is not being enforced, leading to unexpected network connectivity between these tiers. The NSX v6.2 environment is in place, and the security groups and firewall rules appear to be configured correctly within the NSX manager. What is the most effective and professional approach to diagnose and resolve this microsegmentation enforcement failure? Option A. Focus troubleshooting efforts on the physical network switches and cabling connecting the hosts, assuming a physical layer issue is causing the logical policy failure. Option B. Verify the logical configuration of security groups and firewall rules. Check the distributed firewall status on affected hosts. Examine NSX Edge Services gateway logs and review NSX Manager logs for errors. Option C. Immediately disable the micro-segmentation policy to restore expected application connectivity and investigate the issue later. Option D. Proceed with replacing the NSX Edge Services gateway appliance, as it is the most likely component to be malfunctioning when firewall rules are not enforced. The correct answer is B. Verify the logical configuration of security groups and firewall rules. Check the distributed firewall status on affected hosts. Examine NSX Edge Services gateway logs and review NSX Manager logs for errors. Explanation. Scenario analysis. This scenario presents a common implementation challenge in network virtualization where a critical security control, micro-segmentation, is not functioning as intended due to misconfiguration. The professional challenge lies in identifying the root cause of the failure, which could stem from various layers of the NSX v6 2 stack, and rectifying it without introducing new security vulnerabilities or service disruptions. The urgency is amplified by the fact that micro-segmentation is a key component for enforcing the principle of least privilege and preventing lateral movement of threats, directly impacting the organization's security posture and compliance with internal security policies. Correct approach analysis. The correct approach involves a systematic, layered troubleshooting methodology, beginning with verifying the logical configuration of the security groups and their associated firewall rules is paramount. This ensures that the intended policy is correctly defined within NSX. Subsequently, examining the distributed firewall (DFW) status on the affected host (S) and checking the NSX Edge Services gateway (ESC) for any relevant firewall rule enforcement or logging provides visibility into the actual enforcement points. Finally, reviewing the NSX Manager logs for any errors related to DFW or ESG operation can pinpoint specific technical issues. This methodical approach aligns with best practices for network troubleshooting, ensuring that all potential points of failure are investigated in a logical order, minimizing the risk of introducing further issues and efficiently resolving the problem while adhering to security best practices. Incorrect approaches analysis. One incorrect approach is to immediately assume a hardware failure and begin replacing network components. This is a premature and inefficient solution that ignores the software-defined nature of NSX. It represents a failure to apply a logical troubleshooting process and could lead to unnecessary costs and downtime. Ethically, it demonstrates a lack of due diligence in investigating the problem thoroughly before resorting to drastic measures. Another incorrect approach is to disable micro-segmentation entirely to restore connectivity. While this might temporarily resolve the connectivity issue, it completely undermines the security objective of micro-segmentation. This is a direct violation of security best practices and potentially internal security policies, representing a significant ethical lapse as it knowingly exposes the environment to increased risk. It prioritizes immediate functionality over fundamental security principles. A third incorrect approach is to only examine the physical network infrastructure without considering the NSX v6 2 logical constructs. Microsegmentation is a logical construct operating within the virtualized environment. Focusing solely on physical connectivity would miss the core of the problem, which lies in the configuration and operation of NSX components like the DFW and security groups. This approach demonstrates a fundamental misunderstanding of network virtualization and NSX architecture, leading to an ineffective and time-consuming troubleshooting effort. Professional reasoning. Professionals facing such an issue should adopt a structured troubleshooting framework. This involves 1. Clearly defining the problem and its impact. 2. Gathering relevant information, logs, configuration, symptoms. 3. Formulating hypotheses about potential causes. 4. Testing hypotheses systematically, starting with the most likely and least disruptive. 5. Implementing the solution and verifying its effectiveness. 6. Documenting the process and resolution. This systematic approach ensures that solutions are effective, efficient, and do not introduce new risks, aligning with professional responsibility and ethical conduct. Question 9. Examination of the data shows that a critical security requirement for a new application deployment within an NSX v6 2. Environment is to enforce granular access control policies directly at the virtual machine level, ensuring that security follows the workload regardless of its physical location or network changes. Several potential implementation strategies have been proposed. Which of the following strategies best aligns with the architectural principles of NSX v6? 2. For achieving this objective. Option A. Configuring security policies solely on traditional perimeter firewalls at the physical network edge. Option B. Applying security policies at the logical switch uplink interface. Option C. Manually configuring security policies on the hypervisor host management interface. Option D. Implementing distributed firewall rules directly on the virtual machine's VNIC. The correct answer is D. Implementing distributed firewall rules directly on the virtual machine's VNIC. Explanation. The scenario presents a common challenge in network virtualization, ensuring consistent security policy enforcement across a dynamic and distributed environment. The professional challenge lies in selecting the most effective and compliant method for applying distributed firewall rules, balancing security posture with operational efficiency, and adherence to VMware's NSX v6. 2. Architectural principles. Careful judgment is required to avoid misconfigurations that could lead to security vulnerabilities or performance degradation. The correct approach, leveraging NSX's distributed firewall capabilities to enforce policies at the virtual machine's VNIC, represents best professional practice. This aligns directly with the NSX v6. 2. Architecture, which is designed for micro-segmentation and granular security enforcement closer to the workload. This method ensures that security policies are applied consistently regardless of the VM's physical location or network topology changes, providing a robust security posture. It also adheres to the principle of least privilege by applying rules directly where they are needed, minimizing the attack surface. An incorrect approach would be to rely solely on traditional perimeter firewalls or network access control lists, ACL, applied at physical network segments. This fails to address the dynamic nature of virtualized environments where VMs can be rapidly provisioned, moved, or terminated. Such an approach would create security gaps, as policies would not follow the workload. It also contradicts the fundamental benefits of NSX, which is to move security closer to the application. From a compliance perspective, this could be seen as a failure to implement adequate security controls as envisioned by modern virtualization security frameworks, potentially leading to audit findings. Another incorrect approach would be to implement security policies only at the logical switch uplink. While this offers some level of segmentation, it is less granular than applying policies at the VNIC. This approach might not provide the necessary micro-segmentation required for advanced threat containment and could lead to broader lateral movement of threats within a compromised segment. It also introduces a single point of failure or bottleneck for policy enforcement, impacting scalability and performance. Ethically, this represents a failure to implement the most effective security controls available within the NSX platform. A further incorrect approach would be to configure security policies exclusively on the hypervisor host management interface. This is not a design function of NSX for distributed firewall rule enforcement and would likely be unmanageable, prone to errors, and bypass the intended security mechanisms of the platform. It would also fail to provide the dynamic and workload-centric security that NSX is built to deliver, creating significant security risks and non-compliance with best practices for virtualized security. The professional reasoning process should involve understanding the core capabilities of NSX v6. 2. Particularly its distributed firewall. When faced with a requirement for consistent and granular security policy enforcement in a virtualized environment, the professional should first consider how NSX is designed to achieve this. This involves evaluating whether the proposed solution leverages the distributed nature of the firewall and applies policies at the most appropriate layer, the VNIC. The decision-making framework should prioritize solutions that align with the architectural intent of the technology, offer granular control, and provide consistent enforcement across the virtual infrastructure. This proactive and technically informed approach ensures both security effectiveness and operational efficiency. Question 10. The control framework reveals that a new cloud-native application is being deployed within the VMware NSX v6. 2. Environment, requiring granular security policies to protect its sensitive data and ensure compliance with internal security standards. The operations team is concerned about potential service disruptions if policies are too restrictive. What is the most prudent approach to implementing microsegmentation for this application? Option A. Defer microsegmentation implementation for this application until a later date, relying on existing perimeter security controls. Option B. Create broad firewall rules that allow all inbound and outbound traffic for the application's subnet to avoid any potential blocking. Option C. Implement microsegmentation policies in a monitor-only mode initially, analyze traffic flows and application dependencies, and then gradually enable enforcement for specific rules based on observed legitimate traffic patterns. Option D. Immediately deploy strict firewall rules based on general security best practices for web applications to prevent any unauthorized access. The correct answer is C. Implement microsegmentation policies in a monitor-only mode initially, analyze traffic flows and application dependencies, and then gradually enable enforcement for specific rules based on observed legitimate traffic patterns. Explanation. Scenario analysis. This scenario presents a common challenge in network virtualization environments where security and operational efficiency must be balanced. Core difficulty lies in implementing granular security policies without negatively impacting legitimate application traffic or introducing undue complexity that could lead to misconfigurations. The rapid pace of change in cloud-native applications and the dynamic nature of virtualized networks necessitate a proactive and adaptable security posture. The pressure to deploy new services quickly can sometimes lead to shortcuts in security validation, creating vulnerabilities. Correct approach analysis. The correct approach involves a phased implementation of microsegmentation, starting with discovery and analysis, followed by policy creation in a non-blocking mode, and finally enabling enforcement. This aligns with best practices for adopting new security paradigms. VMware NSX, as per its design principles, supports this iterative approach. By first observing traffic patterns and understanding application dependency, administrators can build accurate and effective security policies. Implementing policies in a monitor or audit mode before enforcement prevents accidental disruption of critical services. This methodical process minimizes risk and ensures that security controls are precisely tailored to the application's needs, thereby adhering to the principle of least privilege, a fundamental tenet of robust security frameworks. Incorrect approach is analysis. One incorrect approach involves immediately enabling strict firewall rules based on assumptions about application traffic. This fails to account for the dynamic nature of modern applications and can lead to significant service disruptions, impacting business operations. Ethically, this could be seen as a failure to exercise due diligence in understanding the environment before implementing critical controls. From a regulatory perspective, while no specific regulation is violated by this action alone, it demonstrates a lack of adherence to operational best practices that underpin many compliance frameworks, such as ensuring business continuity. Another incorrect approach is to bypass microsegmentation entirely due to perceived complexity or time constraints, relying solely on traditional perimeter security. This leaves the internal network vulnerable to lateral movement of threats, a significant risk in virtualized environments. This approach represents a failure to adopt modern security best practices and a disregard for the specific security challenges posed by microsegmentation, potentially violating implicit requirements for maintaining a secure network posture as expected by industry standards and potentially by contractual obligations with clients or partners. A third incorrect approach is to implement overly broad firewall rules that grant excessive access, intending to play it safe and avoid blocking legitimate traffic. While seemingly benign, this undermines the core principle of microsegmentation, which is to provide granular, least privilege access. This creates a false sense of security and leaves the environment exposed to threats that could exploit the unnecessary access. This is a failure of professional judgment and a deviation from the intended security benefits of the technology, potentially leading to security incidents that could have regulatory implications if data breaches occur. Professional reasoning. Professionals should adopt a risk-based, iterative decision-making process. This involves understanding the technology's capabilities and limitations, assessing the specific environment and application requirements, and planning for phased implementation. Before making significant changes, especially those impacting security, professionals should conduct thorough research, consult documentation, and ideally, test changes in a non-production environment. For NSX microsegmentation, this means leveraging its built-in discovery and policy management tools to build a comprehensive understanding of traffic flows before enforcing rules. This methodical approach ensures that security is implemented effectively and efficiently, minimizing risk and maximizing operational stability. Question 11. Stakeholder feedback indicates a critical business application requires immediate deployment, necessitating a new network segmentation strategy within the NSX v6. 2. Environment. The project team proposes a segmentation approach they believe adequately addresses the application's security needs, but they are requesting expedited approval to bypass the standard security review and compliance validation process to meet the aggressive deadline. What is the most professionally responsible course of action? Option A. Implement the segmentation strategy as proposed by the project team, relying on their assessment of security needs and assuming compliance with existing policies. Option B. Proceed with the proposed segmentation strategy, prioritizing the business deadline, and document the security considerations for a post-implementation review. Option C. Deploy the segmentation using the default NSX security settings, as they are designed to provide a baseline level of security for all workloads. Option D. Conduct a thorough review of the proposed segmentation strategy against established security policies and compliance requirements before granting approval for implementation. The correct answer is B. Proceed with the proposed segmentation strategy, prioritizing the business deadline, and document the security considerations for a post-implementation review. Explanation. Scenario analysis. This scenario presents a common challenge in network virtualization environments where the need for rapid deployment of new services clashes with the imperative to maintain robust security and compliance. The challenge lies in balancing agility with the strict adherence to established security policies and the potential for misconfigurations that could lead to vulnerabilities or compliance breaches. The pressure to deliver quickly can tempt individuals to bypass or shortcut established procedures, creating a significant professional risk. Correct approach analysis. The correct approach involves a thorough review and validation of the proposed network segmentation strategy against existing security policies and compliance requirements before implementation. This aligns with best professional practices in network security and virtualization, emphasizing a proactive, risk-averse methodology. In the context of the 2V0-642, exams focus on NSX v6. 2. This means ensuring that the logical network design, including microsegmentation rules and firewall policies, directly supports the organization's security posture and any relevant regulatory mandates, e.g., data protection, access control. This approach minimizes the likelihood of introducing security gaps or violating compliance standards, which are critical for maintaining trust and operational integrity. Incorrect approaches analysis. One incorrect approach involves proceeding with the implementation based solely on the project team's assessment of security needs without formal validation. This is professionally unacceptable because it bypasses essential security governance and compliance checks. It creates a significant risk of misinterpreting security requirements or overlooking critical compliance obligations, potentially leading to data breaches or regulatory penalties. This approach demonstrates a failure to adhere to due diligence principles. Another incorrect approach is to implement the segmentation without documenting the changes or the rationale behind them. This is a serious professional and ethical lapse. Lack of documentation hinders auditing, troubleshooting, and future security reviews. It makes it impossible to demonstrate compliance with policies or regulations if an incident occurs. This approach undermines accountability and transparency, which are fundamental to professional conduct in IT security. A third incorrect approach is to rely on default NSX security settings without customization for the specific application requirements. While defaults can offer a baseline, they are rarely sufficient for specialized or sensitive applications. This approach fails to adequately address the unique security needs of the new service and could leave it vulnerable to threats that default policies do not cover. It represents a failure to apply professional judgment and tailor security measures to the specific risk profile of the workload. Professional reasoning. Professionals should adopt a structured decision-making process that prioritizes security and compliance. This involves 1. Understanding the requirements, clearly define the functional and security needs of the new service. 2. Policy alignment. Assess how the proposed design aligns with existing security policies and regulatory frameworks. 3. Risk assessment. Identify potential security risks and compliance gaps associated with the proposed implementation. 4. Validation and approval. Obtain formal sign-off from security and compliance stakeholders after thorough review. 5. Controlled implementation. Execute the changes following documented procedures and change management processes. 6. Post-implementation verification. Confirm that the implemented solution meets all security and compliance objectives. This systematic approach ensures that security and compliance are integral to the deployment process, not an afterthought. Question 12. Quality control measures reveal that users are experiencing intermittent connectivity issues to a critical application hosted behind an NSX Edge Services Gateway-esque cluster configured for high availability. The application is accessible via a load balancer on the ESG. Troubleshooting is required to identify and resolve the root cause of these intermittent failures. Option A. Systematically reconfigure firewall rules on all ESGs in the cluster, starting with the most restrictive settings, to rule out security policy conflicts. Option B. Assume a hardware failure on one of the ESG appliances and initiate a hardware replacement procedure without further software diagnostics. Option C. Analyze ESG cluster and individual ESG logs for errors and anomalies, correlate with network flow data, and perform targeted packet captures on ESG interfaces to identify packet loss or misconfigurations. Option D. Immediately restart all ESG services across the cluster to clear any potential transient issues. The correct answer is C. Analyze ESG cluster and individual ESG logs for errors and anomalies, correlate with network flow data, and perform targeted packet captures on ESG interfaces to identify packet loss or misconfigurations. Explanation. Scenario analysis. This scenario presents a common implementation challenge where a critical network service, distributed across multiple NSX Edge Services gateways (ESC) for high availability, is experiencing intermittent connectivity issues. The challenge lies in isolating the root cause without disrupting the service further, especially given the distributed nature of the solution and the potential impact on end users. The need for rapid resolution, coupled with the complexity of NSX distributed components, requires a systematic and informed approach to troubleshooting. Correct approach analysis. The correct approach involves a phased investigation that prioritizes non-disruptive methods and leverages NSX-specific diagnostic tools. Starting with log analysis on the ESG cluster and individual ESGs provides immediate insights into potential errors or anomalies without impacting traffic flow. Correlating these logs with network flow data and packet captures at key points e.g. ESG uplinks, downlinks, and internal interfaces allows for precise identification of packet drops, misconfigurations, or performance bottlenecks. This method aligns with best practices for network troubleshooting, emphasizing data-driven analysis and minimizing service interruption. It adheres to the principle of least impact, a crucial consideration in production environments. Incorrect approaches analysis. One incorrect approach focuses solely on restarting ESG services. This is a blunt instrument that can temporarily resolve transient issues but fails to identify the underlying cause. It risks further service disruption and does not provide any diagnostic information. From a professional standpoint, this approach is akin to treating symptoms without diagnosing the disease, leading to recurring problems and a lack of accountability. It also bypasses the due diligence required to understand system behavior. Another incorrect approach involves immediately reconfiguring firewall rules on all ESGs without a clear hypothesis. This is highly disruptive and can exacerbate the problem by introducing new misconfigurations or blocking legitimate traffic. It lacks a structured troubleshooting methodology and relies on trial and error, which is unacceptable for critical network services. This approach demonstrates a failure to follow a systematic problem-solving process and a disregard for the potential impact on business operations. A further incorrect approach is to assume a hardware failure on one of the ESG appliances and proceed with replacing it without thorough software and configuration diagnostics. While hardware can fail, premature hardware replacement without exhausting software-related troubleshooting steps is inefficient and costly. It ignores the possibility of logical errors in the NSX configuration, routing, or security policies, which are often the root cause of such issues. This approach represents poor professional judgment by jumping to conclusions and not adhering to a methodical diagnostic process. Professional reasoning. Professionals should adopt a structured troubleshooting methodology that begins with understanding the reported symptoms, gathering relevant data, logs, metrics, configurations, forming hypotheses, testing those hypotheses systematically, and implementing solutions based on evidence. This process minimizes risk, ensures efficient problem resolution, and promotes continuous learning. In the context of NSX, this means leveraging the platform's built-in diagnostic tools and understanding the interplay between different NSX components. Question 13. Research into the security posture of a VMware NSX v6.2 environment reveals a critical vulnerability in a core component that has been recently patched by VMware. However, the network administrator is concerned that the patch may introduce instability into the production environment, which is currently operating without incident. What is the most professionally responsible course of action to mitigate this risk? Option A. Ignore the vulnerability, as there have been no reported incidents of exploitation in the current environment. Option B. Immediately roll back the patch to ensure the current stable state of the production environment is maintained. Option C. Apply the patch directly to the production environment during business hours to minimize any potential downtime. Option D. Conduct thorough testing of the patch in a non-production environment, develop a rollback plan, and then schedule the patch deployment during a maintenance window after confirming stability. The correct answer is D. Conduct thorough testing of the patch in a non-production environment, develop a rollback plan, and then schedule the patch deployment during a maintenance window after confirming stability. Explanation. This scenario presents a professional challenge because it requires a network administrator to balance the immediate need for network functionality with the long-term implications of security vulnerabilities. The core of the challenge lies in accurately assessing the risk associated with an unpatched vulnerability in a critical NSX component. A hasty decision to ignore the vulnerability for the sake of uptime could lead to a significant security breach, impacting data integrity, confidentiality, and availability, which are fundamental tenets of network security and compliance. Conversely, an immediate, unmanaged patch could introduce instability. The correct approach, which involves a thorough risk assessment before implementing any remediation, represents best professional practice. This aligns with general IT security best practices and the principles of responsible system administration. Specifically, for a VMware NSX v6.2 environment, this would involve understanding the exploitability of the vulnerability, its potential impact on the specific network services and data, and the availability of mitigation strategies or temporary workarounds. This structured approach ensures that decisions are informed, proportionate, and minimize unintended consequences, thereby upholding the principle of due diligence in system management. An incorrect approach would be to immediately roll back the patch without proper testing. This is professionally unacceptable because it bypasses the necessary validation steps, potentially reintroducing the vulnerability or causing other unforeseen issues if the rollback process is not managed correctly. It fails to address the root cause of the problem and prioritizes a quick fix over a stable and secure resolution. Another incorrect approach would be to ignore the vulnerability entirely, citing the lack of immediate impact. This is a severe ethical and professional failure. It demonstrates a disregard for potential future threats and a failure to proactively manage security risks. In a professional context, ignoring known vulnerabilities is a direct contravention of the duty of care to protect the organization's assets and data. A further incorrect approach would be to apply the patch without any form of testing or rollback plan. While seemingly proactive, this lacks professional rigor. Unforeseen compatibility issues or bugs in the patch itself could lead to network outages or performance degradation, creating a new set of problems. This approach prioritizes speed over a controlled and secure deployment, potentially leading to greater disruption than the original vulnerability. The professional decision-making process for similar situations should involve a structured risk assessment framework. This typically includes identifying assets and vulnerabilities, analyzing threats and likelihood of exploitation, assessing the potential impact, evaluating existing controls, determining the risk level, and then selecting and implementing appropriate mitigation strategies. This systematic approach ensures that all relevant factors are considered, leading to informed and defensible decisions that prioritize both security and operational stability. Question 14. The assessment process reveals that a critical application cluster in a hybrid cloud environment is experiencing performance degradation, and the security team is concerned about the lack of granular network segmentation between the application tiers. The network virtualization administrator is tasked with improving security posture while minimizing impact on application performance. Which approach best balances these competing requirements within the NSX v6.2 framework? Option A. Configure broad, permissive NSX firewall rules that allow all traffic between application tiers to alleviate performance concerns, with a plan to tighten them later. Option B. Implement microsegmentation using NSX distributed firewall rules applied to security groups. Defining explicit allow rules based on application communication patterns. Option C. Disable NSX distributed firewall enforcement for the application cluster to eliminate any potential performance overhead. Option D. Rely solely on existing physical perimeter firewalls to segment traffic between the application tiers, assuming internal traffic is inherently trusted. The correct answer is B. Implement microsegmentation using NSX distributed firewall rules applied to security groups. Defining explicit allow rules based on application communication patterns. Explanation. The assessment process reveals a common challenge in network virtualization deployments, ensuring consistent and secure network segmentation across a hybrid cloud environment. This scenario is professionally challenging because it requires balancing the agility and scalability benefits of NSX with the imperative to maintain strict security boundaries and compliance with internal policies and potentially external regulations, though for this exam, we focus solely on the NSX v6.2 framework and its inherent best practices, assuming a generic enterprise context without specific external regulatory mandates beyond general security principles. The need for robust segmentation directly impacts data confidentiality, integrity, and availability, making the chosen approach critical. The correct approach represents best professional practice because it leverages NSX's distributed firewall capabilities to enforce microsegmentation at the virtual machine (VM) level. This granular control ensures that traffic is inspected and allowed only between explicitly defined sources and destinations, adhering to the principle of least privilege. This aligns with the core tenets of network virtualization security, minimizing the attack surface and preventing lateral movement of threats. By implementing a policy-driven approach, changes are auditable and repeatable, reducing the risk of misconfiguration. An incorrect approach that relies solely on traditional perimeter firewalls for segmentation fails to address the east-west traffic within the data center, which is a primary concern in modern threat landscapes. This is a regulatory/ethical failure, as it neglects a fundamental security principle of modern network architectures and leaves internal assets vulnerable. Another incorrect approach that involves broad, overly permissive firewall rules creates significant security gaps. This is a regulatory/ethical failure because it violates the principle of least privilege and increases the risk of unauthorized access and data breaches, which would be unacceptable under any general security compliance framework. Finally, an approach that bypasses the distributed firewall for performance reasons without a thoroughly documented and approved risk assessment is a critical regulatory/ethical failure. It prioritizes operational convenience over security, directly contravening best practices for secure network design and potentially exposing sensitive data. Professionals should employ a decision-making framework that prioritizes security by design. This involves understanding the application's communication needs, defining granular security policies based on the principle of least privilege, and then implementing these policies using the most appropriate NSX features, such as distributed firewall rules and security groups. Regular review and auditing of these policies are essential to maintain their effectiveness and ensure ongoing compliance with evolving security requirements. Question 15. Analysis of a new NSX v6.2 deployment for a sensitive data environment reveals that while network connectivity is established and core services are functioning, a recent internal audit has flagged potential gaps in granular access control logging. The deployment team is under pressure to go live immediately. Which of the following actions best ensures compliance with the stringent requirements implied by the 2V0-642 exam's focus on regulated network virtualization? Option A. Rely on the default logging settings provided by NSX v6. 2. As these are generally considered secure and sufficient for most regulatory environments. Option B. Conduct a detailed review of NSX v6. 2. Distributed firewall rules, security group memberships, and logging configurations to ensure they align with documented access control policies and audit trail requirements. Option C. Perform a high-level verification of the NSX v6 to control plane and data plane status, and defer a detailed access control log review to a post-deployment phase. Option D. Proceed with the go-live, assuming that the successful establishment of network connectivity and core services inherently satisfies regulatory compliance for access control. The correct answer is B. Conduct a detailed review of NSX v6. 2. Distributed firewall rules, security group memberships, and logging configurations to ensure they align with documented access control policies and audit trail requirements. Explanation. This scenario presents a professional challenge in ensuring that network virtualization deployments adhere to the specific compliance requirement mandated by the VMware Certified Professional 6 Network Virtualization, NSX v6. 2. Exam's regulatory framework. The core difficulty lies in the potential for misinterpreting or overlooking granular NSX v6 to specific configurations that directly impact regulatory adherence, especially when faced with pressure to deploy quickly. Careful judgment is required to balance operational efficiency with the absolute necessity of meeting all stipulated compliance controls. The correct approach represents best professional practice because it directly addresses the exam's focus on understanding and applying NSX v6 to functionalities within a compliant framework. Specifically, it involves a thorough review of the NSX v6 to deployment against the documented regulatory requirements, ensuring that features like distributed firewall rules, logical routing configuration, and security group memberships are implemented in a manner that satisfies the specific audit trails and access controls expected by the relevant, though unspecified for this exam's context, implying a general adherence to best practices within the NSX v6. 2. Ecosystem, regulatory bodies. This proactive validation minimizes the risk of non-compliance during an audit and demonstrates a commitment to secure and regulated network virtualization. An incorrect approach that involves bypassing the detailed configuration review in favor of a high-level check fails to meet the professional standard. This is because it neglects the critical granularities of NSX v6, 2 that are often the focus of compliance audits. For instance, improperly configured distributed firewall rules could inadvertently permit unauthorized traffic, a direct violation of security mandates. Another incorrect approach, relying solely on vendor default configurations without verification against specific regulatory needs, is also professionally unacceptable. Vendor defaults are designed for general use and may not align with the precise security postures or data handling requirements dictated by the exam's implied regulatory context. Furthermore, assuming that a successful network function automatically implies compliance is a significant ethical and professional lapse, as it ignores the underlying security and control mechanisms that are paramount for regulatory adherence. The professional decision-making process for similar situations should involve a structured approach. First, clearly identify and understand the specific regulatory requirements applicable to the NSX v6 to deployment. Second, map these requirements to specific NSX v6 to features and configurations. Third, conduct a detailed review of the implemented configurations against this mapping, utilizing NSX v6's built-in logging and auditing capabilities. Finally, document the validation process and any remediation steps taken to ensure a clear audit trail and ongoing compliance. Question 16. Which approach would be most effective in implementing microsegmentation using VMware NSX v6 to enhance security while minimizing the risk of application downtime and ensuring compliance with operational best practices? Option A. Focus solely on optimizing network performance by disabling unnecessary security features within NSX, assuming that existing perimeter security is sufficient. Option B. Implement granular firewall rules based on initial assumptions of application communication patterns, prioritizing the most restrictive policies first. Option C. Conduct a thorough application dependency mapping and traffic analysis, followed by a phased implementation of microsegmentation policies, starting in logging mode before enforcement. Option D. Deploy broad security groups with permissive access rules to avoid any potential impact on application connectivity, deferring detailed policy refinement to a later, undefined date. Correct answer is B. Implement granular firewall rules based on initial assumptions of application communication patterns, prioritizing the most restrictive policies first. Explanation. This scenario presents a common challenge in network virtualization, balancing performance optimization with security posture. The professional must evaluate different approaches to implementing microsegmentation, a core NSX v6 feature, while considering the potential impact on application availability and compliance. The challenge lies in the inherent tension between granular security controls, which can introduce complexity and potential performance overhead, and the need to maintain business continuity and meet regulatory requirements for data protection. The correct approach represents best professional practice because it prioritizes a phased, risk-based implementation of microsegmentation. This involves a thorough understanding of application communication flows and dependencies before applying security policies. By starting with a discovery phase and then implementing policies in a non-disruptive manner, e.g., in logging mode initially, the professional minimizes the risk of unintended service disruptions. This aligns with the principle of least privilege and defense in depth, fundamental to robust network security. Furthermore, this methodical approach allows for continuous validation and refinement, ensuring that security policies are effective without compromising application performance or availability, which are critical for business operations and often subject to service-level agreements, SLAs, and regulatory compliance. An incorrect approach that immediately enforces restrictive firewall rules without prior analysis would be professionally unacceptable. This failure stems from a lack of due diligence and a disregard for application dependencies. Such an action could lead to widespread service outages, impacting business operations and potentially violating contractual obligations or regulatory mandates that require service availability. Another incorrect approach, focusing solely on performance metrics without considering security implications, would also be a significant professional failure. This neglects the core purpose of microsegmentation, which is to enhance security by limiting the attack surface. Ignoring security risks in favor of marginal performance gains would expose the organization to significant threats and potential breaches, which could have severe financial and reputational consequences, and violate security best practices and potentially data protection regulations. The professional decision-making process for similar situations should involve a structured methodology. 1. Understand the business and application requirements, including performance and availability SLAs. 2. Conduct a comprehensive discovery of network traffic and application dependencies. 3. Design security policies based on the principle of least privilege, starting with broad policies and refining them. 4. Implement policies in a phased manner, utilizing logging or monitoring modes before enforcement. 5. Continuously monitor, validate, and tune policies to ensure both security and performance objectives are met. 6. Document all changes and justifications thoroughly. Question 17. The review process indicates that the current manual approach to deploying and managing NSX v6, two logical switches and distributed firewalls, is leading to significant delays and inconsistencies across different environments. Which of the following strategies would best optimize this process while maintaining operational integrity? Option A. Develop and utilize infrastructure as code, ISC, templates for the automated deployment and configuration of NSX logical switches and distributed firewall rules, coupled with a version control system for managing these templates. Option B. Prioritize rapid deployment of NSX components by skipping detailed validation steps in non-production environments to meet aggressive timelines. Option C. Implement ad hoc scripting for specific tasks as needed, without a formal process for script management or versioning. Option D. Continue with manual configuration for all NSX components, focusing on improving individual administrator efficiency through additional training. The correct answer is A. Develop and utilize infrastructure as code, ISC, templates for the automated deployment and configuration of NSX logical switches and distributed firewall rules, coupled with a version control system for managing these templates. Explanation. The review process indicates a need to optimize the deployment and management of NSX v6. Two network virtualization components. This scenario is professionally challenging because inefficient processes can lead to increased operational costs, longer deployment times, and potential security vulnerabilities due to delayed patching or misconfigurations. Careful judgment is required to balance speed of deployment with adherence to best practices and potential regulatory compliance requirements, even though this exam focuses on technical aspects rather than specific external regulation. The correct approach represents best professional practice by focusing on automation and standardization, implementing infrastructure as code ISC. Principles for NSX deployment and configuration ensures consistency, repeatability, and reduces the risk of human error. This aligns with the professional expectation of building robust and auditable network infrastructure. By leveraging tools and scripting for repetitive tasks, administrators can free up time for more strategic activities like security hardening and performance tuning. An incorrect approach that relies solely on manual configuration for every NSX component is professionally unacceptable. This method is prone to errors, is time-consuming, and makes it difficult to scale or replicate environments consistently. It also hinders rapid response to security incidents or changes in business requirements. Another incorrect approach that involves ad hoc scripting without version control or standardized templates is also problematic. While it might offer some efficiency gains over pure manual methods, it lacks the auditability, reusability, and collaborative benefits of ISC, increasing the risk of configuration drift and making troubleshooting more complex. A third incorrect approach that prioritizes speed over thorough testing and validation of configurations before production deployment is a significant professional failure. This can lead to network outages, performance degradation, and security breaches, directly impacting business operations and potentially leading to reputational damage. Professionals should adopt a decision-making framework that prioritizes a systematic and automated approach to NSX management. This involves identifying repetitive tasks, evaluating available automation tools and scripting languages, and developing standardized templates and workflows. Before implementing any changes, thorough testing in a non-production environment is crucial. Continuous monitoring and refinement of these processes are also key to maintaining an optimized and secure network virtualization infrastructure. Question 18. The analysis reveals that a financial services organization is experiencing challenges in enforcing granular security policies for its multi-tier applications deployed within an NSX v6. 2. Virtualized environment. They need to ensure that only authorized communication flows are permitted between application tiers, and that sensitive data remains protected from unauthorized access, even within the same network segment. The current implementation relies heavily on traditional network segmentation methods and manual firewall rule updates, leading to security gaps and compliance concerns. What is the most effective and professionally recommended approach to address these implementation challenges and enhance security posture within the NSX v6? 2. Environment. Option A. Implement microsegmentation using NSX distributed firewall rules applied to security groups based on application tiers and roles, dynamically enforcing policies at the VNIC level. Option B. Manually configure access control lists, ACL, on individual virtual machine network interfaces to restrict communication between application tiers. Option C. Increase the capacity and rule complexity of the existing perimeter firewalls to inspect all traffic entering and leaving the virtualized environment. Option D. Rely solely on VLAN segmentation to isolate different application tiers and assume that traffic within a VLAN is inherently trusted. The correct answer is A. Implement microsegmentation using NSX distributed firewall rules applied to security groups based on application tiers and roles, dynamically enforcing policies at the VNIC level. Explanation. The analysis reveals a common implementation challenge in NSX v6. 2. Environments. Ensuring consistent and secure network segmentation across a distributed infrastructure. The professional challenge lies in balancing the need for granular security policies with the operational overhead of managing them, especially when dealing with dynamic workloads and evolving compliance requirements. Careful judgment is required to select an implementation strategy that is both effective and maintainable, adhering to the principles of least privilege and defense in depth. The correct approach represents best professional practice because it leverages NSX's distributed firewall capabilities to enforce security policies at the virtual machine, VM, network interface card, VNIC level. This granular control ensures that security policies are applied directly to the workload, regardless of its physical location or IP address. This aligns with the principle of microsegmentation, a core tenet of modern network security, and directly addresses the need for consistent policy enforcement in a virtualized environment. By defining security groups based on application tiers or functional roles, administrators can create dynamic and scalable security policies that automatically adapt to changes in the environment. This proactive and policy-driven approach minimizes the risk of misconfigurations and unauthorized access, thereby enhancing the overall security posture and compliance adherence. An incorrect approach that relies solely on traditional perimeter firewalls or VLAN-based segmentation fails to provide the necessary granularity for microsegmentation within the data center. This approach is professionally unacceptable because it creates security blind spots within the virtualized environment, allowing for lateral movement of threats between VMs that might otherwise be considered segmented. Furthermore, it often leads to complex and brittle network configurations that are difficult to manage and audit, increasing the risk of compliance violations. Another incorrect approach that involves manually configuring firewall rules on individual hosts or VMs is also professionally unacceptable. This method is highly prone to human error, leading to inconsistent policy enforcement and security gaps. It is not scalable for dynamic environments and significantly increases the operational burden, making it difficult to maintain compliance with evolving security standards. This approach neglects the automation and policy-driven capabilities inherent in NSX, which are designed to mitigate such risks. The professional reasoning process for similar situations should involve a thorough assessment of the specific security and compliance requirements of the environment. This includes understanding the application architecture, data sensitivity, and regulatory mandates. The next step is to evaluate the capabilities of the chosen network virtualization platform, in this case, NSX v6, 2, and how they can be best utilized to meet these requirements. Prioritizing a policy-driven, distributed security model that enforces controls at the workload level, rather than relying on outdated perimeter-centric approaches, is crucial for building a robust and compliant virtualized network. Question 19. Market research demonstrates that organizations are increasingly seeking to streamline their network virtualization operation for improved efficiency and cost-effectiveness. Considering the specific capabilities and limitations of NSX v6, 2, which of the following approaches to process optimization is most aligned with professional best practices and regulatory considerations for maintaining a secure and compliant network environment? Option A. Prioritizing the automation of all network tasks immediately, even those with complex interdependencies, without first establishing clear operational procedures and validation mechanisms for the automated processes. Option B. Implementing a comprehensive, phased approach that begins with a detailed assessment of current network performance metrics and operational workflows, followed by incremental changes with thorough testing and rollback capabilities. Option C. Focusing solely on reducing the number of deployed network services and components to minimize licensing costs, without a thorough analysis of their impact on application performance and security policies. Option D. Rapidly deploying the latest available NSX features and configurations without extensive pre-deployment testing, assuming that newer versions inherently offer superior performance and security. The correct answer is B. Implementing a comprehensive, phased approach that begins with a detailed assessment of current network performance metrics and operational workflows, followed by incremental changes with thorough testing and rollback capabilities. Explanation. This scenario presents a professional challenge centered on optimizing network virtualization processes within the constraints of the VMware Certified Professional 6 Network Virtualization, NSX v6, 2, exam's regulatory framework. The core difficulty lies in balancing the drive for efficiency and cost reduction with the imperative to maintain security, compliance, and operational stability, all within the specific technical and operational context defined by NSX v6, 2. Careful judgment is required to select a process optimization strategy that aligns with best practices and avoids potential pitfalls. The correct approach represents best professional practice because it prioritizes a phased, data-driven, and risk-aware methodology. By starting with a thorough assessment of the current state, identifying bottlenecks through performance metrics and logs, and then implementing changes incrementally with robust testing and rollback plans, it minimizes disruption and ensures that optimizations do not inadvertently compromise security or compliance. This aligns with the implicit regulatory expectation of due diligence and responsible system management, ensuring that changes are made in a controlled and verifiable manner. An incorrect approach that focuses solely on rapid, untested implementation of new features without adequate validation would represent a significant regulatory and ethical failure. Such an approach risks introducing vulnerabilities, violating security policies, or causing service degradation, which could lead to non-compliance with internal standards and potentially external regulations if data integrity or availability is affected. Another incorrect approach, such as ignoring existing documentation and best practices in favor of ad hoc modifications, demonstrates a disregard for established procedures and knowledge, increasing the likelihood of errors and making troubleshooting difficult. This can be seen as a failure in professional responsibility and adherence to industry standards. Professionals should employ a decision-making framework that begins with understanding the specific objectives of process optimization. This involves clearly defining what optimized means in the context of the NSX v6 environment. Is it reduced latency, increased throughput, simplified management, or cost savings? Next, they should gather data to establish a baseline of current performance and identify specific areas for improvement. This data-driven approach is crucial for justifying proposed changes and measuring their impact. A risk assessment should then be conducted for each potential optimization strategy, considering security, compliance, and operational impact. Finally, a phased implementation with rigorous testing and clear rollback procedures ensures that optimizations are successful and reversible if necessary, embodying a responsible and professional approach to system management. Question 20. During the evaluation of a new security initiative to implement VMware NSX distributed firewall rules across a complex production environment, which approach best balances the need for enhanced network security with the imperative to maintain application availability and performance for critical business operations? Option A. Implement the distributed firewall rules in a phased manner, starting with non-critical application tiers, followed by rigorous testing and validation in a staging environment before proceeding to production, with clear communication to all stakeholders throughout the process. Option B. Immediately enable all proposed distributed firewall rules across the entire production network to ensure maximum security coverage from the outset. Option C. Deploy the distributed firewall rules based solely on technical specifications, without consulting application owners or considering the specific operational requirements of different business units. Option D. Postpone the implementation of the distributed firewall indefinitely until a perfect, risk-free deployment strategy can be guaranteed, which may never materialize. The correct answer is A. Implement the distributed firewall rules in a phased manner, starting with non-critical application tiers, followed by rigorous testing and validation in a staging environment before proceeding to production, with clear communication to all stakeholders throughout the process. Explanation. This scenario presents a professional challenge because the network administrator is tasked with implementing a critical security feature, NSX distributed firewall, that directly impacts application availability and performance. The challenge lies in balancing the immediate need for enhanced security with the potential for disruption to business-critical operations, especially when dealing with diverse stakeholder expectations and varying levels of technical understanding. Careful judgment is required to ensure that security enhancements do not inadvertently cause outages or performance degradation, which could have significant financial and reputational consequences. The correct approach represents best professional practice because it prioritizes a phased, controlled rollout of the NSX distributed firewall. This involves thorough planning, comprehensive testing in a non-production environment, and a staged deployment across different application tiers. This methodology minimizes risk by allowing for early detection and remediation of any issues before they impact production systems. It also facilitates effective communication and collaboration with application owners and business stakeholders, ensuring their concerns are addressed and their buy-in is secured. This aligns with the principle of responsible technology deployment, where security is integrated without compromising operational stability. An incorrect approach that involves immediately enabling all distributed firewall rules across the entire production environment without prior testing or phased rollout represents a significant regulatory and ethical failure. This reckless deployment could lead to widespread application outages, data loss, and service disruption, violating the implicit trust placed in IT professionals to maintain business continuity. It demonstrates a disregard for due diligence and risk management, potentially contravening internal IT policies and industry best practices that mandate controlled changes. Furthermore, it fails to uphold the ethical obligation to protect the organization's assets and reputation by exposing it to unnecessary risks. Another incorrect approach, which is to delay the implementation indefinitely due to fear of disruption, also presents regulatory and ethical concerns. While seemingly cautious, this inaction leaves the organization vulnerable to security threats that the distributed firewall is designed to mitigate. This failure to implement necessary security controls could be seen as negligence, especially if a breach occurs due to this oversight. It also fails to meet the professional responsibility to proactively secure the network infrastructure and protect sensitive data, potentially violating compliance requirements related to data security and privacy. A third incorrect approach, focusing solely on technical implementation without engaging with application owners or understanding their specific needs, is also professionally unsound. This siloed approach ignores the critical interdependencies between network security and application functionality. It can lead to misconfigurations that negatively impact application performance or availability, causing frustration and distrust among business units. Ethically, it demonstrates a lack of consideration for the broader business impact of technical decisions and a failure to collaborate effectively, which is essential for successful IT project delivery. The professional reasoning process for similar situations should involve a structured risk assessment, followed by a phased implementation plan with clear rollback procedures. Stakeholder engagement is paramount throughout the process, ensuring that all parties understand the benefits, risks, and timelines. A robust testing strategy, including functional, performance, and security testing, is essential before any production deployment. Finally, continuous monitoring and post-implementation review are crucial to validate the effectiveness of the implemented solution and identify any areas for further optimization.